Welcome, Calculus AB. This is 2-2, basic differentiation rules and rates of change. The essential question is, what's a derivative? Let's begin. We'll skip 2-1 for now because I know you want limits, but we'll hold off. So what's a derivative? Well, one way to define a derivative is it's the slope of a line tangent to the function. So you might have known this notation. You see a circle, and we've talked about the tangent line, and it's perpendicular. But we also can find the slopes of the tangent lines for these other functions. You got this parabola, find the slope there, or the slope right here on the function, or the slope right here. So it's finding the slope at any point in the function. That's our derivative. So what are some notations for this derivative? And you'll see a lot of different notations. You got to get comfortable with all of them. So a lot of times we'll do this notation here. We'll call this f prime. Oh, I can't spell prime. Prime of x. That'll be this notation right here, f prime of x. And sometimes you'll see this notation. We call this dy over dx. So dy over dx. And sometimes you'll see y prime. Sometimes you'll see this notation here. I use that a lot in this notes. Or this notation. They all mean the same thing. They're all finding derivatives. And you might see some similarities between notations you've seen before for f of x or just saying y. So these are all notations for the derivative. All right, so we're going to go over a bunch of basic differentiation rules today. And the first one is called the constant rule. So the derivative of some constant c is 0. So it's always 0. So no matter what number it is, so there's no variable. And that might make sense if you graphed a graph of a function. It'd look like this, a straight line. And the slope's always going to be 0. So that makes sense to me. So the function y equals 7, the derivative, y prime would equal 0. F of x equals 1, your f prime of x will equal 0. S of t equals negative 3. Well, s prime of t is going to equal 0. And then y equals k pi squared, where k is some constant. K is a constant. These don't get tricked by a variable. They're all constants. So that means y of prime is going to be 0. All right, let's try the power rule. So this is another rule. If we have x to some number, so x to like 5 or x to x squared, so we have a rule for finding the derivative. So for f to be n is a rational number, then the function f of x equal x to n is differentiable, and it works this way. So basically you have your x to some power, it equals n times x to the minus 1. Yeah, I kind of think about it as I take this x to the 5, and I take that 5 and put it on the outside, and then you minus 1 that 5. So x to the 5th will become 5 times x to the minus 1/4 power. Let's do some other examples. So if f of x equals x cubed, the derivative, you take that 3 to the outside as a coefficient and knock it down 1. F prime of x is going to be 3x squared. The next one, g of x equals the cube root of x. So this is not that same notation, but let's convert it to a power notation that I can use. The cube root of x is the same thing as x to the 1/3 power. So I can do the same thing. I can take that 1/3. It's going to be a coefficient on the outside. It's going to equal 1/3. And then you're subtracting 1 from 1/3. So you're going to get times x to the negative 2/3 power. And let's not leave it in that format. Let's not leave it as negative powers. I can write that as 1/3 or 1 over 3 times x to the 2/3 power. And if I wanted to be fancy and write it as radical form, because that's what we started with, let's do that. It's going to be 1 over 3 times the cube root of x squared. So those are that sequence of notations. The last one, 1 over x squared. Again, I want to have this in the numerator to follow my rules. So I'm going to write that as x to the negative 2 power. And then that's going to be, so negative 2 comes to the outside, x, and knock it down a stack and becomes to the negative 3rd. And to rewrite that as a fraction, negative 2 over x cubed is your derivative there. Let's do some more. So constant multiple rule. What this says is I'm multiplying some function f of x by some constant c. That equals that c times the derivative of that function. So basically that constant means whatever you get, just multiply by the constant. So let's do some examples here. You got y equals 5x cubed. That's going to be y primed. It's going to equal, well, 5 times 3, knock that out, x squared. And let's write that a little neater. That's going to be 15x squared. All right. This next one, y equals 2 over x. So y prime is going to be, well, take the 2 out, and I'm going to write that 2 times x to the negative 1. And the derivative of that, so it's going to be 2 times negative 1 x to the negative 2 power. So I'll have negative 2x to the negative 2 power, and writing that as a fraction, that'll be negative 2 over x squared. Moving on from that, you see the pattern here. It's the 4/5 of the outside times 3. Oh, not 3. I'm going backwards. I'm just starting to get thinks I'm too good at this. So times 2, 2t. And we can write that as 8t over 5 or 8/5 t, whatever you want. That last one down there. Okay, so I'm going to write that as 2x to the 1/2 power. And I'm going to pull out that 1/2, so it'll be 2 times 1/2 x to the negative 1/2 power. And those 2's, that 1/2 and that 2 are going to cancel. So I'm x to the negative 1/2 power, and we can rewrite that as x1 over x to the 1/2, which can be rewritten as 1 over the square root of x. And if I didn't want to leave it in that format, we can write it as square root of x over x. Yeah. Moving on. Sum and difference rules. A lot of words here. What does this say? So you have two differentiable equations, f and g. Basically it says, well, if you can add them, then you can differentiate them separately, and subtracting, differentiate separately. So the way I think about this is each separate term you do the derivative separately. So for this example here, I'm going to do the derivative of this, and this. So derivative of x cubed is going to be 3x squared. Derivative of negative 4x is going to be minus 4. And derivative of 5 is 0. So I can write that answer as 3x squared minus 4. So you just do each term separately. That's all it means right there. Okay, derivative of sine and cosine, because yes, we can find derivative of trig functions. So the derivative of sine equals cosine. And the derivative of cosine equals negative sine of x. So let's use that right here. If I have these functions, I'm going to try the derivative. So y equals 2 sine of x. The derivative of that is going to be y prime is going to equal 2 cosine of x. And the next one, so sine of x equals 1/2 sine of x. So again, y prime, or let's write this dy dx. Choose the other format too. So it's going to be 1/2 cosine of x. And the next one, we have two terms here, but just find the derivative of each term. So that's going to be y prime equals 1 plus, or we could say minus, but let's say negative cosine. Not cosine, come on. Negative, everything went away. Y prime equals 1 minus sine of x. That's what I wanted to do anyways. Moving on. Rate of change. So we did a few of those examples. This is another thing where we use the derivative here. So derivatives can be used to determine the rate of change of a variable. And so this is a cool way we can actually apply this, because we can apply this to population growth, production rates, motion of objects. So actually what we're going to do today is the motion of objects. You know, you've talked about distance and velocity and acceleration before. So our distance function is going to be written as s of t, because t is our variable time, and velocity is v of t. And you've talked about the rate is distance times time, t, and the variations of that. So another way to write this is the change in distance divided by the change in time. So we're going to go delta s over delta t. So that is another way to write our rate here. And so if our s of t function, s of t is the position function, and it's moving in a straight line, one neat relationship between these two functions is the velocity equals the derivative of the distance function. Whoa. So we're applying our derivatives right here. Also, what you want to know is speed of an object is the absolute value of the velocity, because velocity can be, when we're talking about these functions, you can have positive and negative, because negative would be like going down and positive would be going up. But when we talk about speed of an object, it's the absolute value. We want to know how fast it's going, even if it's going down. Let's apply this to a problem. So we have a diver. So at time t, a diver is jumping off a platform 32 feet above the water in this figure right here, and he's fallen. So because the initial velocity of the driver is 16 feet per second, position of the driver is this function right here. And I want to know, when does the diver hit the water, and what's the driver's velocity at impact? So 2 points right here. And here's my function again. When does he hit the water? So that's going to hit the water when your s of t is equal 0, because that's like your kind of your y value. So when you hit 0, boom, you hit the water. So we're going to do that by regular old factoring. So 0 equals negative 16t squared plus 16t plus 32. Now, I can, since these all have a common factor of 8, I'm going to divide everything by 8. So I get 0 equals negative 2t squared plus 2t plus 4 divided by 8. Didn't show that work, but I think you can figure it out. Whoa, I could have divided by 16. So let's divide by another 2. So I get 0 equals negative t squared plus t plus 2. And the neat thing, usually we're going to be factoring here. We don't usually have the negative term in front of the x squared. So we're going to divide by a negative 1. So we get 0 equals t squared. Basically flip the signs. Minus t minus 2. All right, I'm going to factor this. And if you factored that form, that's going to be t minus 2 times t plus 1. So our two solutions for t are going to be t equals 2 and negative 1. But this is the real world. And he's starting at time 0. So does that time of negative 1 make sense? So we're only going to use, what time does the diver hit the water? T equals 2 seconds. All right, now that we know when he's hit the water, what's the driver's velocity at impact? And we know that velocity is going to equal the derivative of the distance function. So I'm going to say velocity of time. Velocity equals s prime of t, which is going to equal the derivative of that is going to be negative 16 times 2t plus 16, and that's it. And so that can be written as negative 32t plus 16. So now I want to find the velocity impact is basically going to happen in velocity at 2 seconds. So that'll be negative 32 times 2 plus 16. So that's going to be negative 64 plus 16, which will be negative 48. But what are our units here? When we're talking about the real world, we're talking in feet per second here. So negative 48 feet per second. And that's my answer. That's it. Stopping.